In this video, I'm gonna go over a few AIs that I developed to play 3 simple Fortnite minigames. I've thought for years that training neural nets to play games would be very useful to automate some playtesting for game developers and help competitive gamers discover new strategies, especially when a big patch rolls out and everyone is racing to find the new meta. That's why 4 years ago, I made the AI Learns to Play Mortal Kombat video as a proof of concept. And a few months after that, I tried to do the same thing for League of Legends, but it was really hard, so I thought, okay, I can wait a few years for the research to improve and companies to build useful tools that I can use myself as an indie game developer and esports nerd. Well, fast forward 4 years, and the branch of AI used to train game agents actually hasn't improved very much.
This branch of AI is called deep reinforcement learning, and it works by feeding the current state of the game to the model, often in the form of a stack of recent frames. The model predicts what actions the AI should take, and then the programmer writes something called a reward function that evaluates how good or bad the actions were. In a game like Mario, the reward function could be as simple as a small positive number when Mario moves to the right and a big negative number when Mario dies. After spending enough time training and tweaking the setup, AI will hopefully learn to choose actions to maximize reward.
Even though OpenAI and DeepMind have beaten top pros in Dota and StarCraft years ago, nobody took this research and made useful tools for competitive gamers and game developers. Nobody even made it easier for the average developer to build stuff with this AI. So I decided to put together a simple and well-documented Python project teaching AI to play Fortnite through real-time screen capture. Let's go over a few models I trained and talk about some useful things that you can do with this code.
But first, in case you've been MIA for the last 7 years, Fortnite is a battle royale where 100 players fight on an island to be the last player or team standing, while looting for weapons, items, and building materials. In the last year, Fortnite made their modding tools way better, so I've been making these Fortnite custom games called maps. The top maps have as many concurrent players as a top 50 game on Steam, but don't worry, I'm not in this for the attention, I just love beating up teenage boys.
He snuck up on me!
Currently, there's no way to train AI in Fortnite, and even though it'd be very hard to get AI to learn the main Battle Royale mode, I think I can train something simple that can be useful for playtesting my maps, and maybe it'll give me some ideas for how to train more complex AIs that could be used as esports practice. So I set out to be the first person to get reinforcement learning working in Fortnite. I started this project in February and put together what I thought was an easy game mode for AI to learn. These are 2 separate neural nets at the beginning of training, fighting each other with an assault rifle and infinite ammo. The reason it's 2 neural nets is because a common technique when training game AI is self-play, where AI learns by playing against itself or previous versions of itself. This works because as the AI improves, the opponent also improves, so the game difficulty increases during training. I didn't do self-play because Fortnite doesn't let you run 2 instances of Fortnite on the same PC, and I wanted to avoid syncing models across multiple PCs in my prototype. But I thought I could achieve a similar result by running my training script separately on 2 PCs, having them fight each other while both AIs improve independently. If you've played Fortnite before, you probably noticed that I disabled the main mechanic Fortnite is known for, building and editing. If you don't know what that is, it looks like this.
Oh my god!
At the time, I had just launched my first Fortnite map, Guard Commander. My background is in Unity, but many of the top esports started off as mods of other games, which allowed the developers to launch faster and leverage an existing community. My goal is to build a top esport, so I got into Fortnite modding because it seems like it is the best developer ecosystem. The Unreal editor for Fortnite was easy for me to pick up. Actually, the hardest part about making Guard Commander was learning how to play Fortnite.
I keep re-clicking the left button, that's what's killing me.
Yes, it's an odd mechanic to start. There's not a lot of games where you do that.
Specifically the building and editing mechanic. I was grinding ranked in Battle Royale for a few days, and even though I had smooth sailing from bronze to plat, I was heavily relying on my strategy of running away from everybody with an occasional lucky kill. And then I would make it to endgame and die, because in endgame, you actually have to be decent at building, and I sucked at it. I figured if I was having a hard time learning this mechanic, then it would probably also be hard for AI, so I disabled it during training. If I wanted AI to learn interesting Fortnite strategies, then I would need to enable building, but I wasn't expecting the first version to be good enough for players to practice against. This was supposed to be a proof of concept to see if the competitive community would be interested. and also to see if I could use the AI myself to automate some playtesting for my maps, to find bugs and come up with ideas. Besides this AI, I've been working with my friend Coach Doty on a 1v1 offense versus defense map called Steal My Wall, where the attacker must kill the defender, and the defender must survive the time limit while staying inside their box. I'm the weakest playtester we have, and I still find bugs or things to change every time I play, so the bar is very low for AI to be useful. When I first thought about AI playtesting 4 years ago, I was living in Toronto, now I'm in San Francisco and about to move out. Living in the generative AI echo chamber here makes me wonder if all the hype around other branches of AI have actually slowed down reinforcement learning progress. I made the first training map a small box and gave both AIs 1 HP, so there would be lots of killing. And then I used text recognition to detect when a player is eliminated. This gives a reward or a punishment to the AI, so it learns to maximize killing and minimize dying. I ran multiple experiments with this first setup, but all of them had the same problem. After a few hours, it would learn to hug the walls in the corners, which is good because it's more protected and gives a better view of the rest of the map. But aiming was terrible, and after a few more hours, it would get more terrible. One of my experiments was to give AI a small reward when it's facing the other player. I did this by using the YOLO object detection model to detect the other player model. I had to make sure that the YOLO model would not activate when it only detects the current player. So that's why one of the players is not a human, but a chicken. I was very proud of this scientific breakthrough, but ultimately, it didn't make the AI any smarter. So, I needed to kill the chicken. I knew I had to make big changes, but it took a month and a half to get to this point. And I was determined to get my chicken dinner. So I took what I had and did some user testing. So the game is, you have 1 minute to kill the chicken as many times as you can.
Your chicken is the bot?
The chicken is me. Once we start the game, what I'm going to do is I'm going to load up an external Python program, and then it's going to start simulating keyboard and mouse inputs.
Let me just figure out how to shoot again. 1.
Yeah. There you go.
Alright, let's go. Let's run it, bro. I'm ready. The crosshair is on this chicken's head. Oh,
Oh shoot.
Go chicken.
What the?
oh fuck. Dude, this guy's shooting the roof.
What? Okay, that was pretty much it.
It didn't find me. It felt like it wasn't trying to look at me.
2 obstacles differentiated my project from most game AI research. The first is that I'm training on a single real-time instance of Fortnite. Typically, complex game AIs either train on multiple instances of a game in parallel or in a sped-up instance of the game. The second obstacle is that there's no way to explicitly pass data from Fortnite to my PyTorch model, which is why I'm using screen capture. I knew that if I built a game in Unity or Unreal Engine, it would be way easier to train AI to play it. But if I wanted to use AI to playtest my Fortnite maps, and if I wanted to eventually train AI on popular closed-source esports, I don't see a better solution that doesn't have these obstacles. So in the next set of experiments, I removed unnecessary parts while still training on a single real-time instance of Fortnite and still using screen capture. Instead of 2 neural nets, we now have 1 neural net, fighting against the default guard. I disabled moving the crosshair up and down, because the guard and the player are always at ground level. And I also disabled movement, so all the AI can do is pivot horizontally, jump, crouch, and shoot. Intuitively, reducing the possible actions should make it easier and faster for AI to learn something reasonable. I still thought that having a small reward for facing the enemy could help training, even though I previously saw no benefit with the YOLO object detection. So I implemented a simpler version of this, which uses image detection for the visualized audio icon to give AI a small reward when there are footsteps in front of the AI that a human would be able to hear. I streamed multiple training experiments on Twitch, including this one, which I ran for 45 hours. But it still sucked. So, I made another even simpler map. Shooting requires precision, so I got rid of it. The goal of the new map is to run to the metal square as fast as you can. Once you reach it, it teleports to another random location. I permanently pressed down the W key to move the AI forward and disabled other movement keys. AI can only choose between one of 3 actions: look left, look straight, or look right. I also switched to using the DQN algorithm because it's supposed to be better at learning with low amounts of data. Finally, after 2 months of experimentation, it worked. The easiest way to tell is that the average reward kept increasing for the first 2 days of training, which means AI kept reaching metal squares faster and faster. It's not as good as me, but it's clearly turning to face the metal squares, and it has no hard-coded knowledge about what these metal squares are. AI was trained by getting a reward when this blue text appears. Yes, I could have hard-coded it to move towards the metal trigger, but the fact that it figured this out on its own through computer vision and reinforcement learning means that it'll be able to figure out more complex tasks that I can't hard-code, like building and editing. On GitHub, I've documented how to run the model, how to train your own model, and how to visualize the processing that the model is doing on the screenshots. You might be wondering, from the first experiment to this one, which one of the changes was most important for getting AI to actually learn something? And I don't know, but here's everything I tried. The next step is to train it on a real Fortnite map, and the best map I've worked on is Steal My Wall. I like competitive multiplayer games that are easy to pick up but hard to master.
There, I messed it up.
Steal My Wall is a competitive map that helps you practice an essential skill that's hard to learn in other maps. We first designed it for top Fortnite players, got great feedback, and now we're adding tutorials for the average player like me. This has been a 2-month project, and between this and the AI, I haven't had much time to play Fortnite. So it's time to start practicing.
Build a wall, bottom left corner edit.
Let's start with some build edit
Build a wall,
drills.
peanut butter edit.
Here you can practice taking good peeks from different positions. Most rely on the strategy of right-hand peeking, which means you usually want to build cover on your left, so you can peek over on the right and shoot the enemy while they can't see you.
Build wall, right window edit. Build a wall.
You can only edit a piece that you place yourself, so a common strategy is to steal your opponent's build, by destroying it, and immediately placing your own. Stealing is the main mechanic in our game, so we set up this tutorial section with a bunch of different scenarios where you might want to steal a piece. And we've got audio guides and screenshots to tell you how to do it.
This diagonal setup from above is one of the most common ways to steal a wall in pro gameplay. This is a very difficult angle for your opponent to hit a shot on you from. Another strength to this setup is that you have multiple options if they do happen to hit a shot on you. You can reset the wall, the flat, the roof. You can also create even more distance between you and your opponent by editing the roof and going up to take height.
Once you've done the solo practice areas, you're ready for the main game. 1v1, attacker versus defender in 7 scenarios. It'll probably still be hard and that's intentional. I did all the programming for the map and I'm still bad at stealing pieces.
Oh, we got a chance here.
That's why I teamed up with Coach Doty, who did most of the game design, and why we got insanely skilled playtesters. AI is never going to replace human playtesting, but it can automate the boring parts, and reinforcement learning is the easiest way to do it.